We're looking at homework from section 5.2. This is question number 6. In a recent year, the scores for the reading portion of a test were normally distributed, with a mean of 21.2 and a standard deviation of 6.8. Complete parts A through D below. So we'll start with part A. Find the probability that a randomly selected high school student who took the reading portion of the test has a score that is less than 18. So we need to find the z-score associated with an x value of 18 using the formula z equals x minus mu over sigma. So z equals 18 minus 21.2 over 6.8. That's negative 3.2 over 6.8, which is negative 0.47. So because this z-score is negative, we need the negative side of the standard normal distribution table. We take our z equals negative 0.47 and we find a table value, and the table value associated with that is 0.3192. Because we're looking at a probability that x is less than 18, then less than area is the table value. So the probability that x is less than 18 is 0.3192. That's your answer for part A. In part B, we're looking for the probability that a randomly selected high school student who took the reading portion of the test has a score that is between 16.5 and 25.9. So we'll need to find two z-scores here. I always start with the z-score farthest to the right, which would be the z-score associated with x equals 25.9. We plug that into the z-score formula, and we get z equals 25.9 minus 21.2 over 6.8, which is going to be 4.7 over 6.8, and that is equal to 0.69. So when z is 0.69, we need the positive side of the standard normal distribution table, and that gives us a table value of 0.7549. What about for the x value of 16.5? Well, z is going to be 16.5 minus 21.2 over 6.8, which is going to be negative 4.7 over 6.8, which is negative 0.69. So that means our z-score here is negative, and we're going to need the negative side of the standard normal distribution table. So when z is negative 0.69, our table value is 0.2451. So when we're looking for the probability that x falls between two numbers, then we need to take the table value that's farthest right minus the table value on the left. So that's going to be 0.7549 minus 0.2451, which is going to be 0.5098. And that's your answer to part B. In part C, we want to find the probability that a randomly selected high school student who took the reading portion of the test has a score that is more than 35.3. So we need that z-score associated with x equals 35.3. So we get 35.3 minus 21.2 over 6.8, which is 14.1 over 6.8, which divides to 2.07. So we have a positive z-score, which means we need the positive side of the standard normal distribution table. We look up our z-score of 2.07 and we find a table value of 0.9808. Because we're looking for the probability that x is more than 35.3, we're going to need 1 minus this table value. So 1 minus 0.9808 is 0.0192. That's your answer for part C. Part D asks if any of these are unusual, so let's recall the values that we had from parts A through C. In part A, the probability was 0.3192. In part B, the probability was 0.5098. And in part C, the probability was 0.092. The way we determine if a probability is unusual is whether or not its probability value is less than 0.05. So are any of these less than 0.05? And the answer is yes. The answer from part C is unusual because it's less than 0.05, And that reflects answer A. That's your answer.